In the past years, I worked in different agile projects with agile methodologies and had the chance to improve my knowledge regarding continuous integration and continuous delivery, which is really important if we are talking about time to market. Time to market, we often can say that this is for the competition, but in the end, it's about the money, to be as fast and ship things to production as soon as we can. And in this presentation, I would like to share some lessons learned or some tips what I learned and could be useful for you as well. So regarding the agenda, we will check first the system under test, what we are shipping basically to the customers, to the users. And to understand how we can ship this, we need to talk about the legacy system. I call this as evolution. There's always a part when you try to make some improvements on your system, and in the end, you will realize that you need to start something from the scratch, and I call this as the revolution process. So in the beginning with the evolution, we had to decrease the time to market from 2 weeks to 1 week, and we could do this by improving the small steps on the pipeline. But with the recent changes and from the request from the customer, we had to move to another kind of level, introducing new technologies. So let's talk about some system under test, what we are shipping to the users. This is a UI-heavy application, a web application, for a leading travel company where millions of users are basically visiting this page daily, and we have 1,000 pages to hit. And the users can be potential travel users who are looking for hotel accommodation, looking for flights, but can be crawling bots, for example, for Google or Yahoo, and different specialists as well. Regarding the work who is responsible for this project, we have 8 teams from 4 continents. So this is an extra case in our study. And we have teams in London, in Montreal, in Gurgaon, and here in Hungary, in Szeged too. If you check the page, you will see different modules there. Basically, we are introducing new features and new modules with this process, and by doing some improvements, we can change some part of the system, and we need to verify these so-called modules. So to understand the process with time to market, we need to talk a bit regarding continuous integration and continuous delivery. Continuous integration is basically development practice. It means that you have one common code base, and you want to get something for this. You want a build from this. You want this build to be self-testing, and the best way to do is to introduce unit integration and UI test as well. And we want this build to be self-testing, because early defect detection is really important there. And basically, the continuous delivery thing is an extension of it. So if you have a working code base where everyone can work from this, they can pull a working code, then you can move to the next phase and deploy this to test environment, do some kind of manual testing or UI testing there, and you can go even further and deploy changes to production. And in this way, you can release it to the work and basically to the market. In this process, we can say that every change to the system is a release candidate. And if we are talking about the evolution process, the legacy system, let's have a look on this deployment pipeline. This is the best way how you can visualize the processes, the steps, how a change can go to production. So we had the engineering community responsible for submitting the changes to the main build. If the main build is okay, so here we have the CI, then we can deploy the changes to a test environment. We can do manual and UI testing there. And we did this for a week. And this was a continuous process. And after a week, a third-party team responsible for deploying changes to integration deployed all of the changes to integration code environment. And there we had a day to do manual test and UI test. And if everything was okay there, we had the chance to deploy this to production. So this was the old way, the legacy system, how we shipped features to production. And the time to market for this was 1 week, basically. And we had issues there a lot. Let's have a look on this. So regarding the build, you can have issues with the continuous integration right at the entry point because the main build was blocked 40 and 60% of the time. We had one repository and someone failed to run unit test or PMD or check test. Then the build was broken. If the build is broken, you cannot submit your code changes. And we had a lot of engineers there having the need to use this main build. I mean, more than 100 of users wanted to have this. And we were blocked sometimes for a day. And regarding the UI test, UI automation test, we had a lot of automated tests. We had more than 9,000 UI tests in this system, and that's a lot. And the deployed integration happened even if the test failed, and this wasn't a good thing. And this integration environment wasn't really a better environment or a stable environment because basically you use the same test endpoints, we use the same test data and the same infrastructure for this. And there we had the chance to basically to do this request, to decrease this 1 week cycle to a couple of hours. We had to move to another infrastructure and a smaller community. And if we are talking about decreasing the time to market, basically we need to decrease each of the steps and have better build times there. And if we are talking about UI automation, then we need to have a look always on the test parameters. Probably unit draw, you need to have a lot of unit tests, a smaller number of integration tests, and a smaller number of UI tests. But teams tend to create a lot of UI tests. And in this way, you can have a reverse pyramid, and that's a bad thing because you need to follow this structure because of the early defect detection as well. And in our case, we had this kind of pyramid. It's probably can be a bit unknown for you because we had a lot of unit tests, but still had a lot of UI tests as well, and just a small number of integration tests. And to improve our test strategy, we had to, and to fix this, from the draw, you can see that we just need to find the way how we can decrease the UI test and move this to the integration level. And usually when we create UI test, in our case, we created a lot of unhappy scenarios and moved this to the UI level. So if we are talking about the new build, in the deployment pipeline, let's check it. So we still have the engineering committee. Now it's a smaller one, but still we can have on a daily basis, we can have 50 or 60 people working on one build. But now we introduced new technologies. We changed the version control system to Git. And now we introduce feature branching. And with feature branching, we basically created infrastructure when each feature branch is representing a feature build. And feature build is having the same configuration as the master build. We run the same unit test, the same integration test, the same UI test as well. And plus the newly created test as well. And in this case, it's nearly impossible to break the main build because you cannot merge your feature into the master if these tests are failing. We also changed the infrastructure there. The technology stack, we moved to Grace application. So if the build is okay, if the build is green, then we can deploy this change to a test environment. Then we can go ahead and do our UI testing there with automation. Now we use a Selenium supported tool for Groovy application, which is Jab. And if this phase is okay too, then we can do a deployment to production. So now we are not deploying changes to integration, but right off to production, and with the help of the AWS, Amazon Web Services. So with Amazon Cloud Techniques, you can have a blue-green deployment. It means that you have two instances. One is blue and one is green. And the traffic is blue instances, but you can still do a deployment to green instances and do the UI testing there. And if everything is OK with the green instances, then you can move the traffic there. And we can still run UI test before they are released to the users. And this is a really cool way for releasing to your changes. It can give you extra trust. And then we can release it to the world. We also introduced different kind of environments for testing. So on development, we use stub data for UI testing, or aka we can say it as a service virtualization. Also, obviously, when we test on test environment, we use test data. And with this new technology, we can use the production data before we release our changes. So when you move to a new technology, which in this case was Grails, you're always trying to find the way how you can test this application. And in this way, we find the way how we can decrease it with the help of the Groovy server pages, aka GSP. What does it mean? So GSP is responsible for rendering views in Grails. That's OK, because with UI testing, we always try to find the way how we can test the views. They are pretty similar like active server pages or ASP. You must be familiar with that, or GSP. So if you have a look on the page and have a look at the background, for example, on the index.gsp file, you can see that we can list each of the modules there, what we want to render on the page. And each of the modules included there can represent another GSP file. If we can go deeper, and now let's check just a module. Let's focus on that. And let's go to the HTML view of it. Usually, with WebDriver supported tools, we always try to write some kind of test against it, because it's fun, it's easy. But for that, you need to render the whole page, and you end up having UI test. But if you can go deeper, if you find the way how these HTML files basically are generated, in our case, we find the GSP, the related GSP for this module. And if you can give a data for it, then we can manipulate this file. And we can use stamp data for it. For example, we can see how this module is behaved when we give 10 links against it. Or without links, we can render it. And the cool thing is that you can run these modules parallelly and without opening a browser, just generating the related HTML file. And this way, we found something, how we can move the UI test to the integration level. And in my case, I always try to find a way with this kind of test that you need to find something how you can test these modules separately. Because testing unhappy scenarios are really important. This can be a good way for that. You can do this with the JavaScript as well. And I think this is one of the best way how you can keep the same coverage, but still having important tests. And if we check the related tests for it, you will see these steps. They stands for BDD. So behavior-driven development. We really like to use this. We really like to use this on unit level, on integration level, and on UI test level as well. Because, so BDD is an agile testing method. It means that you have specification. And if you have specification, you want to use that in your test. And in this way, we want to insert these acceptance criteria into our test. So in our project, when we had a lot of teams from Montreal, Gorian, it means that we can use BDD as a specification handover. For example, if we are submitting a feature to this main build, and we are going home, then the team after us, which is Montreal, can know more about this newly shipped feature. And if there is a problem, they can read the specification, and they can fix it, or they can make a no-go decision if there is a real problem with the software. And the same goes for the other team, which is Brisbane. So in this way, we are basically communicating with each other with these BDD-supported tools, and this helped a lot to basically have a better cycle between the teams. So we talked about how we decreased, how we moved the UI test to integration level by separating these modules. And then you will have UI test, basically just sanity check. We use Cucumber for that, also BDD supported tool, and we just check the module there. If the module is there, the business logic is tested earlier with another kind of level. And in this way, you can end up having the correct pyramid. So why is it important? Why is it good? In our case, from the business, we often get decision to do A/B testing. It means that you have one module with different views. You can say that there is some kind of difference between these modules. Some have description, some have some ratings or other buttons. And earlier, we tested these options with 6-page loads. Now we just need one. And we can do the rest of the logic, the testing of this logic on the integration level. And in this way, you can save a lot of time. And we had more than, 50, 60 A/B tests. So you can save a lot of time with this approach. So when you are building this pipeline, you should have some kind of tests. I'm pretty sure you have some desktop UI test. Pretty sure you have some kind of responsive tests or cross-browsing tests. We have. And we recently introduced the visual test. Yesterday, we had a really good presentation about it. So in a nutshell, what does it mean? So you have a baseline image, just part of the page, some from the module before the change. Then you can get this picture after the change, and you can make a differentiation about it. And it can give you an alert if there is a problem with the product. And earlier, this kind of test passed because you still have the title, you still description, button, so integration and the UI level test passed. But still, there is some fishy there. It can give you an extra level of support, basically, in this case. And another thing is the monitoring. With AWS, you can set up alerts, and we can say that the users are the best testers we can have. They can visit a lot of pages, and if there is a problem with it, then we can get an alert. In this case, there is this high bar because some of our pages were unavailable, and we can roll back, we can do what we need to solve this issue. So regarding what we have gained, what should be followed at other projects, and what I will follow in my new projects. So you always need to find the way how you can have this integration layer. Because earlier I also skipped this. But now, if we are talking about releasing faster, shipping faster, we need to have this. Without this, we cannot have this kind of test. I really like Selenium. I have experience with it, but you need to find another way to test it. Because you can decrease the time to market by having these steps and having this kind of integration test and running them parallel. And if you are working with multi-locational teams, then BDD supported tool is really a need, I think. And if you are working with cross-functional teams, where basically developers are responsible for writing these tests, you can still have this BDD style of test, because manual testers without IT knowledge can work on these tests, and they can insert the acceptance criteria into unit test, into integration test, and even on the UI test as well. The previous code that I showed you was from a manual tester who hasn't had any IT knowledge, and it was a really nice code, and he created that. And in this way, you can end up having steps for test, which is fast. You should have deterministic test, and then an isolated environment. We will talk about a bit later. And for me, it's really important to have this process whole transparent. Keep it simple. It's just a view from our Jenkins view, and each box is representing some kind of test for master build, for acceptance test, for responsive test, or visual test. And if there is a problem with one of the steps, then you can find a way to fix it. And you can run them parallel, and inside the suites you can still run them parallel too. So you can save a lot of tests with it, and the whole process should be simple in this way. But you can have a lot of tests. You can have a really good scalable system with parallel runs, but it's still, I have to say, it's not easy being green. It's not easy to have a green pipeline, and we had a problem in it. Let's have this example. So for example, you have a test suite failed. Then you check the result, you see that it must be an environment issue, you saw that passed fast, or you see from the screen that this should pass. They run the test case, you see it's passed, and they can make a go decision to release it to the world. Then another day, you see the test failed, you rerun them, you see the test failed, but now the previously failed tests are passed and new one introduced, and the new one are basically failed. You rerun them, you're suspecting it's an environment issue, and you realize the test passed without any changes. And you can make a go decision to release to the world. And this is really bad, because in this way you can keep losing your faith in your test. And you start to make this as normal, that red test failed is okay, but it's not. And this is because of the thing called flaky test, or non-deterministic test. It means that if you have a system without changes, these tests are sometimes failing, sometimes passing without any notification, and you need to eliminate from this from your test suites, because you will end up releasing real bugs. And we had this, and we had to work on that. And for us, this was the biggest challenge with the whole community, with these more than 100 people, to keep this pipeline green. And this was the main thing for me, to eliminate this kind of tests. And this is not easy. Thank you, everyone.
Thank you, Gabor. And let's see the questions. I'm going to pin the first one. Yes, you can see them with.
Yeah, I expected this question about exploratory testing. I would always ask them. Yeah, or we can say manual test. On feature benches, we are not, but we have manual testers who are basically doing some kind of demo at the developer. So at the developer's machine, they can check this feature bench and do some kind of exploratory testing there at the development phase. Obviously, on the test and even on production, they do another kind of testing. Yeah.
Okay. Thank you.
All right, can't you convert some of those tests to API? Yeah, I think if you have a setup, you need to know the project. In our case, we can't, but I can imagine other projects where you can do this. Yeah, and you should follow that. Yeah, supporting this idea.
All right, thank you very much. Let's go to the next one. When you decrease the UI tests, how did you choose which one you automate in the new flow?
Yeah, so basically with this new setup, we wanted to keep all of these checks. So we didn't remove new checks, just remove them to a lower level. So basically, we kept the same test and introduced new ones. So we kept the same coverage.
Okay, thank you very much. We still have some time for some more questions. And actually, there are a lot of questions. So next one. Besides modules, did you use other methods to decrease test execution time?
Yeah, well, this is how we introduced you may remember the draw from the Jenkins. You can have these tests parallelly, these of the steps. You can generate a lot of suites, for example, regression suites, responsive suites, and beside the suite where you have, for example, responsive tests, you can run them parallelly too. So in this kind of test, it's wholly scalable.
Okay, we have time for 2 more questions. First one, do you have dynamic content in your web app? If yes, how do you test it?
We don't have the dynamic content, yeah.
Okay, then it's a quick question.
Yeah, but yeah, it's an interesting topic, yeah. With visual tests, you can do masking there. We try to do that. If we would have the dynamic content with masking, you can eliminate them from the suites. Yeah, you can do this, I think. Yeah, but really interesting one.
Definitely.
Good question.
Okay, so we have one more question. Which tests do you run in prod? Aren't you affecting the reservation systems?
So on prod, we just run the sanity check, just checking if the modules are appearing there. If they're appearing there, it's because we have data for it, and earlier the feature is tested with different happy and unhappy scenarios. Yeah.